Hello and welcome to this presentation in which we will show you some practical equipment features and loss testing procedures. First, how do you choose the right equipment for optical loss testing? This is usually a trade-off of 5 factors: skill, labour cost, capital cost, and equipment inventory complexity. The two-way tester is a new class of equipment and is now the preferred option unless capital cost is an overriding issue. It has the best productivity, needs the lowest skill level and inventory complexity, but has the highest capital cost. It can also measure optical return loss for no extra effort. A traditional loss test set, or light source and power meter pair, both have lower productivity, need more skill, and are less than half as productive as a two-way tester. The difference between a traditional loss test set and a source and meter pair is in terms of inventory complexity and operating flexibility. A loss test set reduces inventory complexity, but capital cost is higher. A power meter and light source pair increase inventory complexity, but have the lowest capital cost of all, since a single pair of instruments can be separated to measure each end of a link. Now we will introduce 2 light source technical issues which directly affect loss testing accuracy. Light sources may take 10 to 20 minutes to warm up and become fully stable. Worse, this may apply each time the source wavelength is changed, which is a major waste of time, particularly with traditional equipment that only measures one wavelength at a time. Kingfisher has a unique range of premium sources with zero warm-up time, which avoids this problem. In addition, even on our basic sources, Autotest reduces warm-up effects, since all emitters continuously operate with a modest duty cycle. The improved stability of Kingfisher sources reduces the amount of referencing activity in many situations and greatly enhances measurement confidence. The second issue is optical source connector stability, which can cause much frustration and wasted effort. Singh will now demonstrate the repeatability and stability of Kingfisher source connectors. A source is turned on and the meter is referenced. The source connector is repeatedly reconnected. Note that each time the power level settles back to within 0.1 dB of the original value. This connector stability greatly improves test confidence and productivity. Now we will look at test leads. Low loss test leads are required, with both the fibre and connector types matching the system to be tested. The test leads are attached to the instruments and left in place during testing. On multi-mode systems, a mandrel wrap is used at the light source end or at both ends for a two-way tester. Arrangements should be in place to clean connectors each time they are inserted. Inspect the connector end face regularly with a microscope and replace test leads and through connectors after about 1,000 insertions. It is bad practice to use the instrument connector itself for testing. Various test standards specify from 1 to 3 test leads when performing referencing. In our demonstration, we will use 2 test leads. Practical loss testing is always the same few steps. This is technically called the insertion loss technique. First, a light source is connected to a power meter using a pair of test leads and a through connector, and the meter is zeroed or referenced. Then the test leads are connected to the device under test. The power meter now displays the loss value in decibels. Accuracy using this method is usually limited by light source stability, connector repeatability, and power meter linearity. Tests using this procedure are limited to small work sites because of a fundamental problem: how to take the two power readings a long way apart and over a limited time period to limit source drift. One solution would be to use a power meter each end of the link to take the two readings. However, if one meter is inaccurate, the results will be wrong and no one will know. To solve this problem, the bidirectional or two-way loss test method has been developed and widely adopted. This method ensures an accurate and repeatable outcome, although it is very labour-intensive with old-style equipment. Since it involves double testing each fibre, poor test results can be eliminated. To correctly calculate the average of 2 decibel readings requires that they are first converted to linear units, averaged, and then back to logarithmic decibels. Of course, this is best performed using a spreadsheet. Using modern test equipment and software, the two-way test method is fast, accurate, and can be used on any work site, so it is today's preferred method of loss testing. For example, a customer evaluated a pair of Kingfisher two-way testers with KITS software by testing and reporting on a 288 fibre cable installation. To their surprise, they completed the job in 2 hours. Using traditional equipment, they estimated that this job would have taken several days. Such a dramatic time saving can make the difference between profit and loss on an installation job. Alternatively, two-way testing can be done with simpler equipment, using a 2-step process. However, this is of course much more complicated and time-consuming. We will now show 2 methods of referencing a pair of two-way testers. First, the local referencing method is used for testing small losses where high accuracy is required. The two-way ports of both instruments are connected, and the set ref button is held down. The instruments now both display 0. When instruments are used further apart, remote referencing is used. In this arrangement, each instrument is referenced to itself, and a reference is taken independently on each instrument. This method is not as accurate, but it is convenient and accurate enough for system acceptance testing. We now continue to demonstrate loss testing with a two-way tester. Here, one instrument is connected to a computer which has the KITS software running. Remember that in practice, the 2 instruments could be far apart. First, a remote reference is required, which we have just done, so each instrument now reads 0. After remote referencing, autotest is turned off and restarted on just one instrument. The instruments are connected to the device under test. Autotest synchronizes and displays the bidirectional loss in real time on both instruments. Alternatively, pass or fail can be displayed. To record this measurement in the customer report, a mouse is clicked on KITS, and in about 8 seconds all values are recorded on the customer report, including optionally the return loss each end. Alternatively, data can be stored in the instrument memory. When the values are recorded, the hold symbol on the remote instrument flashes, so that the remote operator knows the reading is done. Both operators now can move to the next fibre, and when he's ready, the remote operator pushes hold. This simple communication arrangement lets two users work through a fibre frame without talking. You are now watching bidirectional, two-wavelength loss and optical return loss acceptance testing being performed at a rate of only a few seconds per fibre, with the pass-fail acceptance clearly indicated as the test progresses. When the technician finds a problem, they can use the real-time display to identify and rectify minor issues without interrupting the test progress. The simplicity and speed of this method is the reason why this new class of instrument is so popular. We will now show a loss testing procedure using a pair of traditional loss test sets. First, we connect one instrument to a computer with the KITS software. Next, to take a reference, each instrument is connected in a loopback. And the reference button is held down. Each instrument now reads 0. After remote referencing, Autotest is turned off and restarted at the light source end. We connect the remote light source through the device under test to the power meter attached to the computer. Autotest synchronises and displays part of the measurement in real time. Note that at this point, the remote reference value cannot be seen at the power meter. To record this measurement, a mouse is clicked on KITS, and in 8 seconds, half of the lost test data is recorded. Alternatively, the data could be stored in instrument memory. Both operators now move to the next fibre. A voice channel is required at this point. The measurement process is repeated in the opposite direction. And the data is conveniently recorded into the remote power meter memory. At the end of the test, the remote power meter is returned and attached to the computer. And the results are downloaded into KITS. It is not until this point that the exact pass-fail status is determined. So if there is a problem, the technicians must go back and repeat the measurements. Whilst not as fast and efficient as a two-way tester, this process is still twice as fast as using non-Autotest instruments. The testing process for a Kingfisher source and meter equipped with Autotest is identical. Not all power meters can connect to KITS software. For example, obsolete Kingfisher instruments, KI3600 instruments, or instruments from other manufacturers. In this case, data can be manually entered into KITS, so the same method of presenting data to clients can be used. This makes KITS a true enterprise-level solution for capturing and reporting field test results.
Thank you for watching our presentation. We trust you found this valuable.